All right, in this video, we'll be determining the slope of this line, and this is a mass versus volume graph. So the slope that I'll be calculating would be, slope is rise over run. And the rise, in this case, is my y-axis, which is my mass. And the run, in this case, my x-axis, which is my volume. I'm just going to shorten it by putting volume. And mass divided by volume equals density. I'm going to shorten that just by putting dense. Okay, so the slope is the density of this graph. Now, there have been a lot of misteachings of slope over the years in a lot of classes. And not to point fingers, that's certainly not what we're here to do. We're only here to teach you the correct way. In our science classes, we refer to points that go through corners as friendly points. Now this, my circle, is a friendly point. It goes through a corner right there. I see another almost friendly point there. That's a pretty friendly point there. And right there looks like a friendly point also. Okay, and you could probably take any of the three. I always prefer to take the two furthest apart. Don't use the origin, and do not ever use any of your data points. That's absolutely a no. That's not acceptable. If you try to use these data points, you'd be saying those data points are perfect points. They were measured by humans. They have human error in it. We need the average. We do not need individual points. You're not allowed to do that. So what we do is we find on the graph where it goes through corners, and that's called our friendly points. So I've got my two friendly points. And then there's various ways to do this. I've always kind of been partial to making a little right triangle out of it. And we got to find out how much it rises. And sometimes you've heard teachers say, well, count the blocks. Do not count the blocks, because counting the blocks only works if you went by ones. We did not go by ones. We went by twos when we did our axis. And so I have to see where I started my rise, and I started my rise at 18. And I rose up all the way to 62. So think of it as a tall building, and you start on the 18th floor, and you have to go up the stairs to the 62nd floor, long ways up. How many floors did you go up? That's your rise. 62 minus 18 is 44. So I officially have 44 as my rise, and that'd be 44 grams. Okay, now I look at my run. My run is when I go this way. Running goes left to right, rising goes bottom to top. So my run started, again, at this point, which if I go down to the bottom, it started at 2. And I ran all the way to this point, which if I go down to the bottom, happened to be exactly at 7. So I started 2 in, and I ended 7 in. That would be a difference of 5. 7 minus 2 is 5. Now, again, you cannot count blocks because we did not number by ones, so that does not work. You can't count blocks. Okay, if you number by ones, you could, but very rarely in true science do things just happen to go by ones. And that'd be 5 milliliters. So we would have a slope equal to 44 grams divided by 5 milliliters, which you can then go take your calculator and take 44 divided by 5, and you would get 8.8 grams per milliliter. Okay, we now have our slope, and we now know what our density is. I now have to go to an outside source, look up, maybe Google metals that have a density of 8.8. Maybe look at the periodic table, and there's probably 4 or 5 elements that have a density near 8.8. And the element that is closest to 8.8 that also looks reddish brown in color happens to be copper. And so I would then make my prediction that this element is copper. And in the next video, we will show how you can prove what your percent error is and how accurate you were with your results.